For all of you who have been here with me, thank you. This is open to all Microsoft internal employees, our entire Microsoft Partner Network. We're glad to have you here, especially for our session today with CloudEndure. We have Gonen Stein on with us, who is going to give us an overview of CloudEndure. And I'm really, really excited about this one because CloudEndure provides the only solution in the industry today that can replicate virtual machines from any platform to any platform. On-premise to cloud, cloud to cloud, cloud to on-premise. And I think you're going to be really excited about what you see. Very, very useful as we get involved in Microsoft Q4 deals, and just a great thing to help our customers who have a strong desire to be multi-cloud. So I hope you enjoy the session. I hope you learn a lot. And Gonen has contacts for you at the end that you can reach out to learn more.
So what we do, as a recap, is enable workload mobility. And you can see here on the left-hand side a diagram that kind of illustrates how many of our customers see CloudEndure and tell us how they envision CloudEndure whenever they start using it. And we decided to just draw it up because that's what people started telling us. They told us that it feels to them when they're using CloudEndure like they're able to teleport workloads from point A to point B. And you can see a little teleportation guide, the teleporting guide that moves from one point to another. Another way to think about CloudEndure is if any of you have used Ghost in the past, like taking Ghost images and then bringing up the Ghost image in a target machine after taking it from the source machine. With CloudEndure, the experience will be very similar to having a Ghost image that you can always use and will always work without any ifs, ands, or buts. It'll always, you know that a Ghost image will always come up because it's an identical clone of the source machine that you've taken. But the kicker here with CloudEndure is that, actually there are two kickers. One is that Ghost image, if you will, is always going to be live, up to date, down to the second or down to the sub-second with CloudEndure, given our technology, and I'll talk about that in a moment. And the second kicker is that CloudEndure also handles the cross-infrastructure conversion, because a traditional Ghost image was only good for the same type of hardware that you took it from. But when you're looking at cross-infrastructure mobility, and especially cross-cloud mobility, moving from, let's say, AWS to Azure, you can't just magically expect the system to come up and work natively in the target infrastructure. And that's the other thing that CloudEndure takes care of. And this is what customers feel when they start using CloudEndure. The common use cases for this type of technology, as you can probably allude to, is disaster recovery. That's a big one. So ensuring business continuity for workloads from any source infrastructure to the target of your choice, in this case, Azure, and doing so while dramatically reducing cost, because cloud and DR is kind of like the perfect marriage, because you finally have a way to not have to pay for duplicate everything, duplicate infrastructure, duplicate compute, storage, licensing, and only pay for what you use when you need it. So that's a very common use case for CloudEndure, using it for DR in the cloud or to the cloud. Another one is live migration, moving workloads. And we're seeing another one picking up quite quickly, which is DevOps staging. So customers who rapidly change their code, rapidly change their services, and they want to make sure that they test them out in a staging area in a continuous way and not have to wait every time for the data to get replicated. So we see a lot of customers doing that as well. But primarily we're talking about DR. So the primary drivers around the DR product are to minimize the cost of infrastructure, software licensing. We provide enterprise-grade recovery objectives. So the RPOs, recovery point objectives, with CloudEndure are measured in sub-seconds. So it's truly continuous replication of your workload from point A to point B, and recovery time objectives of mere minutes. Within minutes, we can recover the systems. Another thing that our customers like about, and our partners, of course, in benefit of customers, like about CloudEndure's technology, is that it allows you to perform an unlimited amount of DR drills in a non-disruptive fashion without stopping anything in the source application or without impacting performance, so that you always have that peace of mind. If you're providing as an MSP, if you're providing a DRaaS solution to your customers, disaster recovery as a service solution to your customers, what they will always ask you is, what's going to be the impact of my business when you deploy the solution? And how frequently can I ensure that everything is going to run when I need it to run? So this allows you to do that quite quickly. And then finally, it sets the stage for literally a one-click future migration into the cloud. Because once you've had a DR solution set up, some customers are simply not ready to move to the cloud just yet, but they definitely want to reduce their business continuity costs. Once you set up the solution with CloudEndure, you're literally one click away from finalizing your migration into the cloud whenever the customer is ready. And that brings me to the next use case, which is live migration. And again, the way that CloudEndure is positioned by our partners to our customers, and also by our cloud provider partners, is that it's designated for mass migrations, right? It's not, if you're looking to move 1 or 2 servers or even tens of servers, you can probably do it manually. Customers sometimes do it on their own. But when we work with enterprises, and enterprises really want to be able to set it and forget it and move a mass amount of servers, mass workloads into the cloud, and also ensure that there is near zero downtime during the cutover, because it's one thing to move a lot of servers, but if you need to bring down your business operation for many hours or sometimes days, that's not a good thing. And CloudEndure allows you to avoid that. It allows you to take a massive number of servers and replicate them, keep them live, replicated into the cloud without disruption, without any kind of disruption. And whenever you want to flip the switch and cut over into the cloud, you can do it within minutes. And similarly to our DR, the unlimited non-disruptive DR drills, we also provide an unlimited number of migration drills. So you don't have to close your eyes and hope for the best and cross your fingers before you cut over. You can test it in a non-disruptive way in what we call a staging area before the cutover time arrives. And when you cut over, you literally repeat your drill one last time and flip the switch into the cloud. And there is no need for any kind of application-specific expertise because CloudEndure replicates at the block level. I'll talk about that in a moment, and allows you to really eliminate infrastructure lock-in because we can help you go from any infrastructure into the cloud. All right, so and again, remember guys, if anyone has any questions during the session, feel free to put those in the chat dialogue with Karl, or you can just also ask questions at the end. So let's get down into the technology itself. So I've talked about the use case. I've talked about what makes CloudEndure unique from a business perspective. Let's talk about how this actually works behind the scenes. So if you look at CloudEndure in our technology, it's broken down to 3 primary pillars that make everything happen, right? So the first pillar of our technology is our replication engine. We have developed our own replication engine that runs at the OS level and conducts continuous block level replication. And what this means is that in the on-premise world, you had the ability to replicate at the storage level, so SAN-based replication, but again, that's not good for cloud because you don't have access to the SAN directly in the cloud. You're not going to have access to the Azure storage directly that sits underneath the hypervisor. Another way of doing so would be in the on-premise world would be to conduct hypervisor-based replication, but that's also a challenge in the cloud. You don't get direct access to the Azure hypervisor directly. With CloudEndure, we've identified that gap, and we also know that a lot of our customers are looking to move physical machines to the cloud, not just virtual machines, and move servers from other clouds into Azure. So we have decided to take a step back and develop something that would make us completely agnostic. And this is what we've done, right? We've developed this OS-based continuous block level replication engine. And the benefits of that are that, first of all, it allows us to become infrastructure agnostic. Allows us, meaning allows you, on behalf of your customers, to become infrastructure agnostic and really move from anywhere. We are also application agnostic because since we replicated the block level and we maintain block level consistency, we are completely agnostic to the applications. It's very common for us to see our partners moving or protecting application workloads, including SQL servers, SharePoint applications, Exchange, Oracle databases, SAP workloads, and many, many homegrown applications that no one has ever heard about. Because to us, it really doesn't matter. We just maintain block level consistency, and the rest is transparent from there. And it's done in a non-disruptive way. So the agent technology that we've developed is installed without any kind of reboot requirements. It doesn't impact performance in any noticeable way, given how we replicate. So we simply read the data from the disk. So it's only read I/O that's very light. And once we've completed reading the data from the disk, there is never any kind of disk impact again, because we sit in memory. The agent sits in memory, captures any block transactions that occur, any writes that occur. We capture them in memory, compress them, encrypt them, and replicate them over the network. So there is no disk impact, and therefore performance impact is completely negligible. And we provide a zero data loss with migrations or near zero data loss in sub-second ranges with disaster recovery. So that's step number one of what we do, the first pillar of our technology. The second pillar of our technology is what kind of does the magic when it comes time to convert the machine from the source infrastructure to the target infrastructure. Because if you only had the technology of moving your storage at the block level, moving the server data at the block level, it wouldn't do you any good if you're trying to move from one type of platform or one type of infrastructure to another. If you're moving from one Azure region to a different Azure region, that may be sufficient. But if you're moving from one cloud into Azure or from on-premise into Azure, you can't just magically expect the systems to come up. And that's why we've developed the second pillar, the 30-second machine conversion engine. And it's literally that. It takes us about 30 seconds to convert the machine end to end. And this includes a bunch of different tasks that we handle behind the scenes, including hypervisor driver injections to the appropriate hypervisor that you're moving into. In the case of Azure, it's Hyper-V. Bootloader changes, networking adapter changes, OS activations, and so on and so forth. So a lot of different things that we handle behind the scenes, and it allows you to really have an any-to-any workload mobility solution. And finally, we have an automated orchestration engine that does it at scale. So it takes the data that was replicated, the conversion takes place, and once the conversion is done, the automated orchestration can spin up in parallel thousands of machines at scale. And for migration projects, you're usually not going to be spinning up thousands of machines at scale. Usually you're going to be spinning up tens of machines or maybe 100 or so machines because you're going to be splitting up your migration into move groups, into these batches. But for DR, when the product is being used for DR, then it's very common for customers to want to spin up many hundreds and sometimes thousands of servers at the same time. And the automated orchestration engine will allow you to do that at scale, and it does everything in parallel. So it doesn't wait for one machine to come up before it moves on to the next one. It does everything at scale in parallel. So that's what we do. That's what the technology pillars look like behind the scenes. And go ahead.
If you don't mind, we've got a couple of questions here in the chat, so figured before we move on, good time to ask those.
Yes, go ahead.
Excellent. So the first one was the software that needs to be installed. What level of access is needed to Windows and Linux hosts? I'm assuming some sort of administrator or root type access to deploy the software.
That's correct. Yeah, on Windows machine, we eventually need disk access, right? And to have disk access, block level disk access, it needs to be an admin on Windows or a root on Linux.
Yeah, perfect. And that's exactly the same as we've seen with other software. Anytime you're inserting a write splitter, something that's going to capture the I/O in the stack, that's that just has to happen. That level of access is required. And the second question is on elaborating on zero downtime. What needs to happen during the cutover from one location to another? I think, I mean, to me it was clear, but I think it's worth kind of clarifying what type, if any type of outage there is during cutover versus installation and normal operations.
Yeah, sure. That's a good question. So I'll actually show a diagram in a moment that describes that in detail, but just to real quick answer the question, the agent installation itself and whatever is needed in order to get the replication started, there is no outage whatsoever, right? We allow you to deploy the agent even though we require this admin access or root access on Linux, and the agent gets installed and starts replicating data directly from the disk. There is no reboot, and this is something that, again, our partners and customers really like, because they initially find it hard to believe that you can do this without requiring any kind of system reboot, but we've worked hard to achieve that, and there is zero disruption. Whenever you plan your cutover, then ultimately you would need to stop your user access to the source infrastructure and redirect the user access into the target infrastructure. So you're looking at a few minutes of downtime during that scheduled cutover window before you actually flip the switch. So CloudEndure always keeps the data in sync. And let's say that, let's take an example, 2 p.m. on a Saturday, you want to plan your cutover window. So at 155, to be on the safe side, you're going to prevent user access into your source environment so that nothing new gets added. That's going to be your downtime window, your cutover window. And then at 156, you're going to spin up the servers in the cloud, and CloudEndure will ensure that they come up in their most up-to-date state from 155. And then at 157 or 158, whenever the servers are up and running, whenever the boot of those servers on the target systems have been completed, then you redirect your DNS, you redirect the end users into the target environment. So you're looking at minutes of downtime during the actual cutover.
Perfect. And one last one that came in here, and I believe the answer is none. I feel very safe saying that, but I just wanted to make sure I didn't miss anything. The question that came in is, what Unix OS versions are supported?
Yeah, you're correct, Karl. So yeah, CloudEndure has a very wide range compatibility matrix of Windows and Linux servers, but Unix is not one of them. So it's x86 Windows and Linux servers.
Yeah, not uncommon at all, especially with any solution that can leverage a cloud infrastructure as a target. You had a perfect point on the underlying infrastructure and not having access to the low-level storage technology, and the same is true for server infrastructure, and that server infrastructure in the really every public cloud that I'm aware of is based on x86 and supports Linux and Windows only, and not proprietary Unix OSs. So no surprise there, and I don't know of anyone that has a different answer.
Yeah, typically what we see is that whenever there are Unix systems, then our consulting partners, SI partners, like probably many of the participants on the call today, would move the application from Unix to Linux on-premise before moving over to the cloud, just to make it really simple. And then they use CloudEndure to move that Linux system into the cloud. So we've seen a bunch of cases where databases were moved from Unix over to Linux using the database copy, just exporting the log and importing it to a different database, or using other database export-import tools, and then using CloudEndure to move the Linux system to the cloud.
Perfect. Thank you very much. That's all the questions for now.
All right, sounds good. Cool, so let's move on. So in terms of this is a question that is very common in the Azure ecosystem, right? Azure, Microsoft has a product called Azure Asset Recovery, ASR, that's also used for both migration purposes and disaster recovery purposes. But evidently, we're seeing a lot of use of CloudEndure in the Azure world. So the question that is begged is why? So we see this as being very complementary to the things that ASR simply cannot do. And this information is information that is basically delivered to us by both our friends at Microsoft, as well as partners that have used CloudEndure in parallel with ASR. And it starts with compatibility. So CloudEndure has a very wide range of compatibility matrices of things that we can support that simply, given the nature of ASR, cannot work with ASR. With site recovery. First of all, since we run at the OS level and are completely agnostic to the infrastructure, we don't run into the limitations of supporting hypervisor versions that are earlier than Hyper-V 2008 R2 on the Windows side, or VMware vSphere 5.1, and any support for other hypervisors replicating from Xen-based hypervisors or KVM or OpenStack-based hypervisors. That's a non-issue for CloudEndure, as well as physical machines that are pretty common when our enterprise customers move their workloads into the cloud. In most workloads we run into, I'd say 80–90% are virtual machines, but it's common to see that the very important servers, like the Oracle databases of the world, in some cases would run on these physical machines, and those are very hard to move, and without being able to move them, moving the rest of the workloads is going to be a moot point. So that's one thing around compatibility. Broader support for different Linux OS distros and versions like Ubuntu and Debian, so those are supported by CloudEndure. And the whole aspect of cross-cloud mobility that's becoming extremely common these days, being able to move not just from on-premise into the cloud, but also from one cloud to another. So AWS to Azure is very, very common, but we're also seeing more and more questions coming up from GCP, SoftLayer, Rackspace, obviously, et cetera. So that's around compatibility. On top of compatibility, there are things around functionality and performance of the product. So CloudEndure is, again, some of you may have already used CloudEndure here on the call. So those of you who have know that it's very, very simple to use. There is no aspect of deploying a virtual appliance, allocating storage, allocating compute. There is no need for that. There's just a software agent that is non-disruptive, which gets deployed on the source machine and starts replicating the data right into the cloud. So much, much more simplified deployment. It's also simple to fail back. This is a question that is also very common. It's a non-starter for many of our customers that want to use cloud for DR. Using cloud for DR and then being able to fail over to the cloud and not fail back is a non-starter, because when disaster is over, customers want to be able to bring their workloads back. Now, in some cases, they stay in the cloud and they just use it to migrate, which is great. But in other cases, if they do want to be able to fail back, we provide a really easy mechanism of failing back simply by reversing that block level continuous replication direction from the cloud-based Azure machine into the on-premise infrastructure or other cloud infrastructure. And this supports back to anything, back to physical machines, back to virtual machines on any hypervisor, or back to other clouds. And it's designed for really heavy workloads, heavy I/O workloads. There is no restriction there. Again, as I said before, it's very common for CloudEndure to be used on extremely intensive Oracle workloads and SQL servers and SAP workloads and other very write-intensive workloads, primarily databases, without impacting any of the application performance. And ultimately provides a near zero RPO and RTO. So sub-second RPO, point objective, and minutes of RTO, also providing granular recovery points that you can roll back into. So if you want to go back to 2 weeks ago in a case of a disaster, or a month ago, or 2 minutes ago, those are all granular recovery points that CloudEndure provides. And I think, Karl, I'll stop here for just a second to see if anyone has any questions before I move on to the next slides that kind of show how this works behind the scenes. But let me stop here for just a moment to see if there are any questions about this slide in particular, because I know that this slide includes a bunch of content, so just making sure that everything comes across properly.
Yeah, great. Thank you very much. So we did have a few questions come in, and you're right, it did prompt them. The questions are around OS support. So what I'm doing in the Q&A is posting a link to the platform support matrix, because the questions that were asked there around Windows 2003 support and CentOS version support are answered right in the platform support matrix. So for the folks asking those questions, that will be in the chat in a second, and you will be able to take a look and see what OSs are supported.
Yep, and I can also kind of give you a glimpse, right? Again, please review the documentation for all the detailed information, but on the Windows side, we do support 2003 and above, so any 2003, 2008, R2, non-R2, 2012, 2016, those are all supported. And then on the Linux side, specifically for CentOS and Red Hat as well, we support version 5 and above. Okay, and Karl, was there any other question that came in, or was that it for now?
No, sir, that is it for now.
Okay, great. Great, so let's move on. So in terms of how this works, I'll start from a high level, and I think this also kind of answers the question that came before around the cutover, right? So if you look at CloudEndure from a high level, the process includes installing the agent on any machine that you want to replicate. And the agent installation, as mentioned before, is non-disruptive, no reboot, no impact on performance, and nothing to configure, right? That's another really important point. There's no need to hook anything into your databases, hook anything into your Windows machines, configure registry settings, whatever. It's completely transparent, because all the agent does is it connects to the block device or block devices and starts replicating the data. Both on Windows and Linux, it's the same experience. And when the agent replication begins, it replicates the data into a very lightweight staging area in the cloud that keeps the data in real-time sync without the full-blown costs of maintaining duplicate compute and duplicate high-performance storage, which you may have had to do back in the on-premise world. So in the cloud, it doesn't need to be like that. You can reduce the cost dramatically. And during that replication time into that lightweight, low-cost staging area, CloudEndure allows you to configure the target blueprint, which in other words means where and how each server needs to be launched whenever the time comes to actually use it. So again, when we replicate the data, everything is replicated into this lightweight, non-functional staging area. You can't use that staging area for anything. The workloads are not running there, and therefore you're not paying for them. You're not paying for your third-party software application licenses, your OS licenses. There's none of that because we only replicate storage in real time, but replicate storage using low-cost storage, block storage devices. But once the time comes to use the workload, CloudEndure needs to know where to bring it up, what subnets to bring up the machines in, what firewall rules to use, what instance types to use, and so on, what IP addresses to assign. So all that can be configured in the blueprint, and then when you're ready to go, you can launch a test. You can launch the machines, either for testing purposes or if you're ready to use them, great, just launch them and start using them. When you test them, this allows you to, again, in a non-disruptive way, it allows you to identify if everything is working properly, if the instances are configured correctly, if the IP addresses are configured correctly, if the machines are spun up in the right subnets. And if you've made a mistake, no big deal. You just go back, make the corrections in the blueprint without any disruption. So switch it to a different subnet, change it to a different IP address, up the instance type, downsize the instance type. It's all very granular and can be corrected at will. And whenever you're ready to go and you've tested it sufficiently and you know exactly how it's going to behave during cutover, then just schedule your cutover or failover if this is a DR situation. And the cutover and failover is really no different than just a standard test. The only difference is that once you complete that final test, you redirect user traffic into the cloud. And this is that downtime, that very short few minutes of a downtime window that I've mentioned before. Now, for those of you who are interested to know what happens under the cover, this slide shows what happens under the cover. So everything starts with the CloudEndure console that any one of you can already go to our website and sign up for an evaluation and see how this works. But basically, you have a web-based access to the console that allows you to define the source infrastructure, the source location that you're replicating from, which could be anywhere, right? Physical environments, virtual environments, or other cloud providers. It's all supported. And then once you define the source that you're coming from, you can define the target that you're going to, so the Azure target region of your choice. And in that target region, you will need to define the staging area subnet where the CloudEndure agents keep the data replication in real-time sync. Now, there is nothing that you need to configure in that subnet. CloudEndure does that for you. CloudEndure does all of that orchestration for you. The only thing that you will need to do on behalf of the customer is to simply create that subnet in their target region of choice and provide the subnet ID into the CloudEndure console so that the console knows where to put the data and where to launch things whenever the time comes to do that. Once you've done that, you can go ahead and deploy the agents on the source machines. Again, no reboot, no disruption. The only thing that the agent will ask you to do is enter your account credentials, the CloudEndure account credentials, so that it knows how to authenticate with the console. So it can be done either using a username and password or a unique token. And once the agent does that, it performs that handshake with the console and it says, hey, Mr. Console, here I am. I belong to customer A, customer B. Please tell me where I need to replicate my data. And the console then makes an API call to the target Azure region of choice and creates this staging area in that staging area subnet. So that staging area, the reason that we're able, or the way that we're able to reduce the cost dramatically, is that for every 10 servers roughly replicating from the source environment concurrently, we create a single tiny Linux-based replication server that keeps the data in sync. And that can scale up and down as needed, but if you do the math, the cost reduction is quite dramatic. In minimal Linux-based replication servers that are very low cost, tiny, and they replicate the data into low-cost block storage devices. And that's the only footprint which gets created in the target environment in that staging area during ongoing replication, during ongoing operation. So until you actually want to start testing your migration cutover or performing the cutover or testing DR, there is no cost for anything other than this lightweight staging area. And of course, there is no software licensing whatsoever because there is no software running here. Your SQL servers, your Windows servers, nothing is really running here. It's just replicating data. After this is done, after the replication staging area is being created and the data replication is ongoing, You can already start to configure the target blueprint, so defining where each server belongs and how it should be spun up when the time comes to use it. And then the last stage, whenever you want to start using your servers, is clicking a button in the console called launch or test. And this sends a different set of API calls to the appropriate target account and creates the actual environment that needs to be used. So we take these volumes from the staging area, they get snapped using their most recent point in time down to the second. They get recreated in the replica subnet of your choice, the target subnets of your choice, where the machines need to come up. This is the stage where the machine converter runs and converts the systems within about 30 seconds. And when the machine conversion engine is done doing its job, it gets terminated, and the volumes that are now post-conversion get attached to the replica instances or to the target instances that are the machines that actually run the applications moving forward. And that's the end of the process. So this end-to-end process of spinning up the machines is going to take merely a matter of about 30 seconds to convert the machines, and then a few more minutes for everything to get ready, and then and then wait for the machine to boot, which again can take a few minutes at the most. All right, so Karl, any questions that came up during this architecture slide?
Yes, there's one that came up, and it is how the question is around how such a low level or a low RPO can be achieved. The exact question was how does CloudEndure achieve sub-second RPO?
Yeah, sure, great question. So here's how the CloudEndure agent works, right? The CloudEndure agent, when installed on the source system, gets put in memory. So the agent replication technology is actually monitoring the disk writes from within memory. So any block write that gets executed, gets committed to the disk, gets immediately captured by CloudEndure's agent. There's no concept with CloudEndure of a periodic sync or taking a snapshot every few minutes. There is no concept of that at all. It's what's called CDP, continuous data protection. So the agent resides in memory, and every block transaction that gets committed immediately gets captured by the CloudEndure agent in memory. That block gets, first of all, checked against the target environment. So we do a block-to-block dedupe, and if we do identify that the block already exists, we're not going to send it over again. But once we've determined that the block does need to be sent over, we compress it, encrypt it, and ship it over the network. And that happens in sub-second ranges, right? It doesn't wait for the block to get replicated in the next interval. It does it in real time. And that's how we achieve the sub-second RPO.
Beautiful. Thank you very much.
All right, excellent. Cool. So moving on, right? Let's see, and this is not going to take more than a few minutes. Since this platform doesn't allow us to see the product in action in an actual demo, we can schedule that subsequently to the presentation. But just to kind of give you an idea of how this actually looks like during this session, I've broken it down to really the four major stages, the four primary stages of using CloudEndure. And this is why the product is really so simple to use. Step number one, when you initially sign up for an account and start using CloudEndure, is simply configuring the account target information. So connecting it to the appropriate Azure account of choice, and then defining your replication settings. And the replication settings allow you to define what target region you want to replicate to, whether for migration purposes or for disaster recovery purposes. And then down here, you can see that there's an option to also use VPN or ExpressRoute if you want to have the data replicated using private connections. We see some customers preferring to use the public internet to replicate the data. We encrypt the data using 256-bit AES regardless, so from a security standpoint, it really doesn't matter. But for the typical enterprise clients we work with, we do see very commonly VPN or ExpressRoute being used in order to, one, accelerate the time of the initial sync, and two, reduce costs. In many cases, the networking costs get dramatically reduced when using ExpressRoute versus just a public internet connection. And that's the first step, right? So configuring your target account. Step number two is going to be deploying the agents. And when you deploy the agents, the agent will show you, first of all, if you look at this application server here that I've installed my agent on, it shows you that initially it will establish the connection between the agent and the console, and then the console will allocate the agent a replication server that may be shared with other agents that are replicating data. So this is the whole connection establishment of the agent with the target server in the staging area, and the data replication will begin. And when the data replication will begin, you will see a progress bar here with a percentage next to it and an ETA that will show you when the initial data replication will complete. Once the data replication is completed, it'll turn into the status that shows here on this MySQL server. So the status will change to continuous data protection because now the initial data sync is completed and now we're just replicating data in real time. The ETA is now not applicable because it's done replicating the initial data set. And the lag time, or in other words, the RPO, the recovery point objective, shows as none. Now, if we do encounter any kind of network disconnection or network saturation where data gets written to the disk faster than what the network can handle, the lag time here will increase. So CloudEndure at that point will show you that your RPO is now higher than none, and it'll show you when the flush will complete. So the ETA will show you when the data flush is expected to complete. So again, just to say here that in any kind of situations of network interruptions or saturations, CloudEndure will know how to handle the situation. Obviously, it'll come at the cost of an increased RPO because the network wasn't there to be able to accept the block traffic, but CloudEndure will handle that transparently. Step number 3, oh, and by the way, here there is another little screenshot that shows a more granular look into the connection establishment. So what's happening behind the scenes whenever the replication of the data gets initiated. Step number 3 is configuring the blueprint. As I mentioned earlier, configuring what instance type is going to be used for each machine when it comes up, what subnet it's going to be launched in, what private IP is going to be used, and so on. So all that can be configured under the blueprint. And step number 4 is just launching the target machine. And so you can see here the checkboxes. You can select multiple machines that you can spin up in parallel. When the machines get spun up, and I don't know if the text here is too small or not, but you can see that we started the whole process here at 8:58 and we were done at 9:03, right? So it took us about 5 minutes end to end to bring up those machines. And it doesn't matter to us if we're bringing up 2 machines or 10 machines or 100 machines or more, as long as the target cloud infrastructure allows us to retrieve those resources, we will do it in parallel very quickly. And the final result is that the machines are ready to use within minutes, and you can see them in the console. There's another tab that'll pop up called Target, and it'll show you the machine information that was spun up in the target region of your choice. So that's how the process looks like with CloudEndure, right? Step 1, configure your account. Step 2, deploy the agents and get the data replicated. Step 3, configure your blueprint. And step 4, launch your target machines without any considerations of what application type you're using, what databases you're using. All that is completely transparent to CloudEndure. And with that, I'll stop here. I've reviewed the content that was planned for the session about who we are, what we do, the technology benefits of CloudEndure, and how our partners use it, and how we go to market. So let me stop here for any other Q&A. Otherwise, you can see the different options for our call to action.
Cool. We've got a great question here around connectivity to the internet, to the cloud. Is a site-to-site VPN connection required, or can the traffic traverse the public internet?
Yeah, anything that you want. We support both.
Yeah, perfect. And we had a lot of questions around bandwidth requirements, and I responded in the chat with mileage varies. That all depends on the customer's change rate, and every customer is going to be different and have different requirements in terms of bandwidth to meet RPO. Are there any modeling tools available to help folks understand the bandwidth required?
Yeah, that's a great question. I think you answered it very well. And there is a modeling tool, so let me answer both. First of all, the mileage will vary. That answer is correct, because CloudEndure eventually will track any block write to the disk. But if the network can never keep up, then it's just the laws of physics, right? We will never be able to achieve a consistent state. If the network eventually can keep up, then we're fine. We don't need the network to always be able to withstand the data traffic, because we know how to handle the situation of a network disconnection or network interruption, and we can also handle it perpetually. Even if the network goes down for 100 years, we will know how to pick it up when the network connection is back up. But again, then your RPO is 100 years. So it's all a question of what is your tolerance for data loss during that time, or your RPO, in other words. And if you know that your RPO tolerance is no higher than 5 minutes, then you will need to ensure that if we can't keep up with, or if the network can't keep up with the replication, you will need to upgrade your pipe before you deploy the solution in order to meet your RPOs. In terms of modeling, we provide the ability to do that. So the agent itself can be installed in a way that doesn't replicate the data across the wire. It just listens to what's going on. And then after, let's say, a few hours or a few days, if you want to be really safe, we can tell you what network considerations you should put in place when you configure the connection between the two sites.
Beautiful. And wow, I got to tell you, I think this is the most active Q&A that I've been a part of. So that's a testament to you, Gonen. You've got people's interest. The latest one that came in is around source disks that are supported. So we have someone that has customers with iSCSI attached disks to their VMs. I'm assuming they mean iSCSI disks to the guest VMs, and also VMDK files that are on NFS data stores. Because the guest operating system doesn't know the difference, I'm guessing that CloudEndure can replicate those.
Yeah, and you are right once again. So again, what we see, what the agent sees, is just a block storage attached to the machine. So the block storage device could be an iSCSI base attached device. It could be an VMDK is mounted on NFS. It could be fiber. It could be physically attached devices. So as long as it's presented as a block storage device, it's transparent to CloudEndure, and we will replicate it, and eventually it'll just turn into an Azure block disk in the target environment.
Outstanding. And question as well about encrypted disks. If BitLocker protected disks or dmcrypt on the Linux side, if those types of source virtual machine disks are supported as well.
Yeah, so we do support them, but the answer is it depends on what process is followed, right? In some cases, you can open up. You need to ensure that at the end of the day, the encrypted disk is accessible in the target environment. So we will replicate the encrypted disk without any issue, because remember, we run at the OS level. We run after the data was decrypted or after the encryption keys are in memory. So we will replicate everything into the cloud. But you will need to ensure that the data or the keys are also accessible in the cloud. So with BitLocker, we have a specific procedure around that allows you to bring up those machines in the cloud. So I guess as a follow-up to this call, whoever asked that question, I'll be happy to set up a call to describe the process in more detail. But the short answer is yes, we do support replicating encrypted disks as well.
That is awesome, and we'll see if we get any more in, but I have one more question so far, and it is around Azure hybrid use benefit. So a licensing benefit that we extended to customers with software assurance agreements. They can effectively reuse their licenses on Azure, and today to support that, a PowerShell script has to be run against a machine once it's been migrated to enable the customer's own license, so they pay a reduced rate for that VM. Is there a capability upon failover or migration to Azure for CloudEndure to run PowerShell scripts against those VMs to invoke a script and make that change?
Absolutely, and another good question. So CloudEndure allows you to run any PostScript of your choice. And actually, my apologies, I was about to talk about that before. But CloudEndure, it's very common for migration projects to always require some type of PostScripting to be launched whenever the machine gets launched in the cloud, and both for DR purposes as well. So you can really launch anything that you want. In very common cases, it's installing new applications that are required in the cloud, uninstalling apps that are not required in the cloud, and as part of that, you can also launch that PowerShell script.
Outstanding. And I'm going to leave Q&A up here for a few minutes, but that was wow, great session. Obviously, a lot of interest from the audience. I literally have never received so many questions, and that is outstanding. And thank you for the answers. All very thorough, excellent responses. Just a great job all around. So really appreciate it, Gonen.
Yeah, my pleasure. Great question. I enjoyed the questions too.
Yeah, this was good. We had a good audience here, and a few folks who are going to reach out to you afterwards about some roadmap items and deeper questions here. Oh, and I just had one more come in that's good to I think good to ask in front of everyone. The roadmap ones I have deferred and asked them to please reach out to you directly for those. But here's a good one. Any consistency group support?
Yeah, so we just.
Oh, I'm sorry. Go ahead.
Yeah, we do support consistency groups across multiple volumes in a certain machine, and we also support consistency groups when we spin up multiple machines in parallel. We can bring them up using a specific point in time.
Beautiful. And there's another one. Somebody curious about the orchestration of recovery operations for DR. How I guess they're just looking for a little more info on that. How recovery orchestration takes place. What can be done? I think that's what they're asking for.
Yeah, sure. So CloudEndure allows you to define, using the user interface, it allows you to define the order in which machines will be spun up. So you can spin up individual machines, you can select a group of machines and spin them up, and then subsequently launch a different group of machines. But what we see many of our customers and partners doing whenever they set up DR deployments at a more grand scale is they leverage our fully documented RESTful APIs. So anything that is accessible within our web-based console is also accessible using RESTful APIs, and we see very commonly customers and partners simply defining their orchestration order based on whatever they want to do using our RESTful APIs directly.
Great, that is awesome. And let me see, I'm going to look one more time, see if we have any more questions. That looks like the last one. Wow, outstanding. And folks, thank you very much for your interest today and your obvious passion about this topic. Great to see I'm not the only one who's passionate and excited about this, nor should I be. Outstanding. True heterogeneous support, platform independence. I mean, this is a really cool topic, really exciting stuff. Gonen, can't thank you enough for your time that you took with us today, for all your preparation you put into it. Obvious the amount of work you did. It was great. And for all the attendees out there, next week we have a little variation in our series. We're going to start earlier than normal. The session starts at 9 a.m. Eastern Time next week, as we have HPE who will be presenting, and they have a couple of folks from Europe who will be leading the discussion on Data Protector and their backup solutions. So really looking forward to that. New integration from HPE supporting Azure as a back-end vault for their backup software. So really looking forward to that one as well. And boy, I cannot thank everybody enough for the attention, the interest, and attendance today. And any questions we didn't get to, please reach out directly to the folks at CloudEndure. You've got two addresses there that you can use: sales@cloudendure.com, and Gonen was kind enough to put his up for folks who are interested in starting a partnership as well. So Gonen at cloudendure.com. Gonen, thank you so much. Really appreciate it, folks. We are going to sign off for this week. And Gonen, if you hang on the line for just a second here, we'll recap amongst ourselves. And I'm going to stop the broadcast right now. Thank you very much, everybody.
Thanks, everyone. Take care.